Hi guys, in today's video we are going to evaluate another limit, and this is going to be easy. This is going to be a fun because we have solved a lot of limits, and I believe that this is going to be easy for all of you. So let's solve question. So we have given this limit x tends to it extends to 4, and I told you thousands of times that x tends to 4 means that x is close to 4. X is not exactly 4, okay? X is not equal to 4. It is very close to 4, okay? So minus 6 divided by x minus 4 whole square. So I have given this limit, and I have to evaluate this limit. So let's do this. So our first step is to apply limit, and this is very easy. Applying limit. So let's do this. Let's apply limit and see what happens. And applying limit means that put x equals 4 wherever we see x in this function. Okay, we have to put x equals 4 in this function. So let's do this. So let me write it in another color. So minus 6 divided by 4 minus 4 whole square, this is equal to minus 6 divided by 0. So this is undefined. This is undefined. It means that the limit does not exist. Limit x tends to 4 does not exist. Let me write it over here. Limit does not exist. Okay, when you solve a limit, when you evaluate a limit and the answer is undefined, so it means that the limit does not exist. So when x extends to 4, when x tends to 4, when x approaches 4, the limit of the given function, the limit of this given function does not exist. And let's solve another question. Let's evaluate another limit. This is also going to be very fun. So limit extends to 0, 1 over x plus 3 minus, okay, into minus 1 over 3 divided by x. So I have given this limit. It says that when x approaches 0, where does this function approach? And we have to find this, and this is very easy. It's not going to be difficult. So let's do this. Let's apply limit and see what happens. So applying limit. Let's apply limit. Okay, so applying limit means that put x equals 0 wherever I see x in this given function. Okay, so let's put x equals 0. So 0 plus 3 is 3, so 1 over 3 minus 1 over 3 divided by 0. So here I get 1 over 3 minus 1 over 3 is 0, 0 by 0. So this is an indeterminate form. This is an indeterminate form, and I can't apply limit directly. First I have to convert this function, okay, this function, okay, which I've been given. I have to convert this function to a determinate form, then I can apply limit. So let's do this. This is basic algebra. This is not difficult. So let's do, and let's first convert the given function to a determinate form and then apply limit. Okay, so let's do this. So limit x tends to 0. So we can take LCM. Okay, so let's take LCM. 3. Okay, over here we can take LCM. Okay, so 3 into x plus 3, so it would be equal to 3 minus into x plus 3, okay, divided by x. Okay, so let's evaluate this. Let's simplify this a little bit more. Let's simplify this. So this is double division, so we can write it together. This is double division, so we can write it together. Okay, so let's do this and multiply minus inside. So what would be equal to 3 minus x minus 3 divided by 3x into x plus 3. Okay, so minus 3 plus 3 both cancels out, x and x it also cancels out. So the final function, the final limit would be limit x tends to 0. I've left over here is minus 1, and this is 3 into x plus 3. Now this is a determinant form, so let's applying limit. Okay, so let's apply limit and see what happens. Okay, so this is a determinant form, so I'm going to get an answer. So let's apply limit and see what happens. So minus 1 over 3, and applying limit means that put x equals 0 wherever I see x in this function. So 0 plus 3 is 3, and 3 times 3, so 3, and minus 1 and 3 times 3 is 9. So this is the final answer. This is the final answer. So it means that when x approaches 0, okay, when x approaches 0, this function that I have been given, this function approaches minus 1 over 9. So this is for today, guys. I want you to practice a lot, because this needs a lot of practice. If you don't practice, you're going to forget this. So I really want you to practice, and please subscribe to our channel, because we need your support, we need your help a lot. Thank you for watching.